All right, a couple more examples here. Let me get the quadratic formula here just so we can refer to that. All right, so I'm going to start out by making my shell. X equals negative b plus or minus the square root of b squared minus 4 times a times c. So notice how the 4 is built in here too, by the way, right? We know why it's there because we did the derivation of it with the completing the square method, but the 2 and the 4 are just built in, right? Those are just part of the formula. All right, so don't forget about those. All right, so basically identify a, b, and c. It's already set equal to 0, so a is 1, b is negative 8, and c is negative 17. So I'm going to put in negative 8 here for b in both these spots. A is 1, so I'm going to put that here and here, and c is negative 17. So now let's operate. So negative negative turns into a positive, so positive 8 plus or minus. Then I'm going to work out what's underneath here. The discriminant, right? Remember that's called the discriminant. So it's going to be 64, negative 8 squared. And then here, and by the way, remember to put this in parentheses, right? The negative 8 needs to be in parentheses, because if you do this on your calculator, you're going to get negative 64, and that's not what we want, okay? So we want the whole value of b squared, right? Not just the 8, but the whole negative 8, right? Because b is that whole value. So when you square negative 8 times negative 8 is positive 64. All right, next we're going to do this. Negative 4 times 1 is negative 4. Negative 4 times negative 17 is positive, and it's going to be 68. Okay, so 64 plus 68 is, let's see, 132. All right, and that is not a perfect square, right? So 132 is not a perfect square. 121 is, 144 is, 132 is not. So what we have to do is simplify that radical. Okay, so if you can, so 132 breaks down, let's see, 2 goes into it 66 times. 66 is 6 times 11. 6 is 2 times 3. So you get a pair of 2's, right? So a 2 comes out, and then you have a leftover 11 and a leftover 3, right? So remember, you disregard these ones. You just look at if this is a factor tree, then we just want to look at the leaves, not the branches, right? So just the numbers that are at the very end, or the very tips. All right, so 11 and 3 goes back inside. 11 times 3 is 33. So this is 233. All right, then on the bottom, we just get a 2. Okay, now we can reduce here, right? Because 8 and 2 and 2 on the bottom all have a common factor of 2. So I can divide everything by 2. So you can only do that when all 3 of these have a common factor. Don't ever divide by what's inside the radical. That doesn't mix. But if all 3 of these have a common factor, you can reduce by that common factor. So 8 divided by 2 is 4. 2 divided by 2 is 1. 2 divided by 2 is 1. These two ones here are optional, right? So I'm just going to write 4 plus or minus 1 root 33. That one is optional. And then the over 1 is optional as well. So I'm just going to leave it like this, right? Don't forget the plus or minus, right? So that's our answer. So you can leave it like that, but you can also write it as 4 plus root 33 and 4 minus root 33, right? It's those two separate answers. So just remember that this means two answers because we have the plus or minus. Now, one other thing I want to note is if they said round to the nearest tenth, then you would plug this in your calculator, right? Or you would plug each of these in your calculator. You do 4 plus root 33, get that answer, and you do 4 minus root 33 and get that answer. And actually, probably what I would recommend is just plugging this in your calculator, and then doing 8, plus this divided by 2, and then 8 minus this divided by 2, and getting your answers that way. That way you don't have to go through this work of simplifying and everything. Okay. All right. That's if they ask to round. If they don't ask to round, I want you to keep it exact and simplified. All right. As usual. Okay. So here we saw a situation where the discriminant is not a perfect square. So if the discriminant's not a perfect square, but it's still positive, so we still got two real solutions, but only only one of them, or excuse me, we got two real solutions, but they were not rational solutions. They're irrational solutions, right? Because we have radicals that didn't simplify. So when this is not a perfect square, your radical will not simplify all the way. That means you're going to end up with an unsimplified radical, which is an irrational number, right? All right, let's take a look at number 6. So here's, we have one side that equal to 0. We have a, b, and c. And so let's set up our shell here. Negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So b is 2, so I'm going to put that here and here. A happens to also be 2, so put that here and here. And c is 3. So here negative 2 comes down plus or minus. Let's do this here. So 2 squared is 4 minus negative 4 times 2 is negative 8. Times 3 is negative 24, right? So this whole thing comes out to negative 24. And so the square root of, or excuse me, 4 minus 24 is negative 20. So the square root of negative 20, now we have a negative underneath our square root, right? So when the discriminant is negative, we're going to have an imaginary number or a complex number. So we're going to have to pop an I out, right? And then we can simplify this root 20. 4 times 5. 2 times 2, so we have a pair of 2s, so 2 is going to come out and then that 5 is going to be left over. So what I have down here is 2i root 5, right? So the I comes out, the 2 comes out, and the 5 stays in. And then on the bottom, 2 times 2 is 4, so I'm just going to put 4 down there. All right, so whenever you have a negative underneath there, whenever the discriminant is negative, you're going to end up with an imaginary number, which means you're going to have two complex solutions, right? Because, yeah, remember this is 2 solutions. So let's simplify a little bit more. So remember, if these have a common factor, you can divide by that common factor. So 2 goes into all of those. So I'm going to divide everything by 2. So this is 1, 1, and 2. So then what we'll get here is negative 1. This one we need because there's no other, and there's nothing else attached to it, right? So we need that one. Plus or minus. This one we don't need because we can keep it invisible in front of everything else that's already there. And we can put 2 on the bottom, right? So if you leave your answer like that, that's totally fine with me. Just remember that means 2 answers. If you're going to do this, if you're going to write this in complex form, then you probably want to split it up. So you have your real and rational, your real and imaginary terms separate. So this will be the complex version of that. All right. So if the discriminant comes out to not a perfect square, then you're gonna, but it's positive, you're gonna have 2 real roots, but they're gonna be irrational. If the discriminant comes out negative, then you're gonna have 2 complex roots. Okay.